Good day everybody and welcome back to the channel. I'm going to get started making up all the wiring looms, wiring harness, whatever you want to call it, for this huge amplifier or two amplifiers in one box, whatever you want to call it. But before I do that, I just wanted to touch on something. I've been looking at my components for the build and I've actually still managed to improve on things even more. So all of these film capacitors were 100 volt rated. I tested 250 volt rated ones and they had lower ESR, better dissipation factor. So these are all now 250 volt 224s and 104s. All of the capacitors that are in here, except, and I'll get to that in a sec, except one, are all really top quality capacitors. That's a Nichicon 220 100 volt VRM. These are ZLH Rubicons 16 volt 1000, and these are FWM Nichicon 100 mic 100 volt. The 47 mic ones for the references for the current sources, they're only Cheng X, misspelt Chong X. That's only for now. I've actually ordered some of these in 47 microfarad. They're on the way. So that is getting changed. The other thing I'm looking into is if I can actually find something. As I explained, the reason I'm using this is because it's actually the smallest thing that's 100 microfarads and is decent quality. You know, if I tried to get 100 microfarad film cap, unless it was something crappy like an MKT or something like that, it's going to be really big. I mean, there's a 4.7. There's a 4.7. Right? So, yeah. And I do want it to be 100 microfarads. So I'm going to do a lot of capacitor research and see, perhaps you can get MKPs that are, you know, small values like 63 volts or even smaller, and, you know, have a better capacitance to size density. I'm going to look into that. The other thing is these MKS capacitors that I have got for the bias. I'm also looking into this as well, the same thing basically, because I got these and they're way too big. They're both MKP. Or I'm wondering again, can I go smaller than 250 volt and find an MKP capacitor to replace those with? So that's upcoming upgrades. Obviously I don't have any of those parts yet. I'm going to be starting the amp build either tomorrow or Monday. So, you know, those upgrades will just come randomly in a couple of weeks or so, if I even find better parts and when I do find better parts. Alright, let's get started with the wiring loom. Alright, one more thing before I get onto the wiring harness. I've been tossing up whether to do this or not, and I've decided I'm going to do it because these are 50 amp or 30 amp bridges. I think they're 50 amp, I can't remember. So they got quite big junction capacitance. The other thing is, this is a 4 ohm amp, 250 watts per channel, which means one transformer rail can see 2 ohms, 500 watt load on it, which is about, I don't know, 15 amps or something. That's quite a bit of current. And when you think about the peak current, well, that could be what, double, 4 times that, you know? Going across such a big bridge, that is going to make quite big spikes. And I'm not just talking about the 100 hertz spikes, but I'm talking about all the harmonics from those switching periods. So I've gone over all the capacitors that I have. I've got a lot of different types of capacitors in here. And I've found that these capacitors still test down in the 5 ohm region, even at 100 hertz, which is bloody good for something that's only 10 nanofarads. See, the thing is, you got two ways of doing this. You can use something that's got sort of like a lossy dielectric, like a Y5U, and you can put it straight across. Or you can use something that's really good like this and form a snubber with a resistor such as these 10 ohm resistors. So that's what I've gone for. Because I've got such big current pulses leading to big spikes, I've gone for the proper solution, which is, you know, a good cap and a low value resistor. So 10 nano, 10 ohm. I'll just show you quickly. So that's at 100 kilohertz, 0.42 of an ohm, 100 hertz. Oh, what? Okay, so it's around 50 ohms. No, wait. This wasn't jumping around before. You can see it's down there. At 1 kilohertz, I think it was, no, even that's really low. Anyway, as you can see, these are good. These are the lowest ESI you're going to really get in this sort of form factor and size, especially at 10 nanofarads. So that's what I'm doing. I do have one other capacitor that I tested for this, and you know, these are really good as well. These are 630 volt, and these are a little bit more expensive. .6 ohms at 1 kilohertz and quite stable. Yeah. So I mean, these are even better. But this is an order of magnitude better than, you know, a ceramic like a Y5U or something like that. I don't think I need to go this far. I think a capacitor that's around, you know, the 20 to 50 ohm mark, which is what I believe these are, honestly. It's hard for the meter to see it at a low frequency, but that is a sort of like a shortcoming of the meter, not so much the capacitor. You see, it tries to stay right down there. These are going to be fine. So, especially for what they're doing, it's just a snubber, you know. And don't forget, like I said, the edge of the spikes, the high frequency content, these are going to knock off bloody wonderful. 10 ohm resistors too. That's quite a stout snubber. So, the only thing I have to do is I have to work out how to fit them. Alright, I got one of them done. That's what I'm going with. The reason I angled them up is because these get mounted like this. So, yeah, we need space on the bottom. Came out pretty good. I'm happy with it. They're not loose or anything like that. It's quite sturdy. In fact, the leg the capacitor's on is quite thick, and I think it's steel. Yeah, so between that and the resistor leg, it's not going nowhere. Don't know if that gives you more of an idea, but yeah. So I'll get the other one made up now, and then I'll get to making up the wiring harness finally. Alright, that's the other one done. So both the rectifiers have got full snubbers for each diode junction. Alright, I'm going to get started on the wiring harnesses now. Oh yeah, by the way, the capacitor banks, I end up adding another 2 of those MKT caps. I just figured, I mean, there's 6 of these, and there's only 4 of those little guys. I mean, they're there for the high frequency stuff, so put, what, 3, 6, 9, 12 in total. Still pretty small in comparison to them, but you got to remember they're dealing with high frequency, so you know they should be a lot smaller. So hopefully the 6 on each bank is enough for that. Alright, I've got some good news today. Got a delivery, and guess what was in the delivery? The polystyrene capacitors that I have been waiting for. So that means as soon as these wiring harnesses are made up, I can start building these amplifiers, and I can't wait. So I got 470 picofarad, 22 picofarad, and there's also 47 picofarad. Oh, there's one. It's one of each, and I have actually tested them. They are all right. I can't remember what the spec was on them. I think it was supposed to be 5%. I think, you know, they're a bit out for 5%, but for what they're being used for, they're perfectly fine. The thing is that's important is that they're polystyrene for stability reasons, i.e. the capacitance and ESR is not going to drift, stuff like that, like with temperature and voltage and all that. So we've got, you know, a really good choice, because these are for feedback compensation stuff. 22.4, okay. I tested one before and it came up as 24. So that's supposed to be 470, that's 485. 44 instead of 47. So yeah, they're a bit off, but like I said, perfectly fine for what we're doing. I might actually, yeah, you know what, because I've got more of them, I'm going to go through the pile and I'm going to select the ones that are closest to value for this amp. I mean, I might as well. I've put so much effort into every other aspect of the design of this amplifier, I might as well at least make sure the capacitors are the correct value. They are, you know, for compensation and feedback stuff, so the values are sort of critical. Alright, anyway, I'll get that done off camera and I'll come back and start making these wiring harnesses up. Alright, so this is what I've got to do. So these smaller pieces of wire basically are going to get made up like this. So 2 will join to one big piece, it'll be soldered and heat shrunk, and then they will go kind of like that. There'll be 2 red ones there, and the same for the other heatsink. So that's how we get power to the collectors. Then these pieces here, one thing to note is every piece of wire is the exact same length, just like the traces are all symmetrical and all the same length. There is a very good reason that I've done this, because I'm sure you all know everything has resistance to it, so I'm trying to keep every single resistance and inductance the same. Capacitance, just trying to keep everything symmetrical. Although, you know, some of the design isn't perfectly symmetrical just because I did it by hand, so I guess capacitance wise things are going to be, you know, off. But I mean, all you're going to get is a couple of picofarads between traces like that anyway, which isn't going to have any effect in this kind of circuit. So for everything that does have an effect, it's covered. These pieces of wire are going to go excuse me, from the end of these resistor banks over to this pad here and this pad here. So there'll be a black wire to there, a black wire to there, and then same thing with the red, kind of like that, like that. So I'm gonna just get all this made up now and then come back and show you what it looks like. And yes, I have made the wires deliberately a little bit longer, but this is going to allow me to do bench testing with it, because obviously I'm not going to just power this up with how powerful it is, and the amount of power that's available to it from the power supply. That would just be really dumb, because if something's wrong, it's going to pop. You know, I was actually, in the first place, not too happy about my design and wishing I used a dual layer board. But I can tell you, I'm actually starting to like this, because to be honest with you, everything is perfectly symmetrical. Everything's really short and thick. I mean, okay, it might be really hard to pull apart, to change devices if they get popped, you know, and it might look like a little bit of a mess and a bit of work, but electrically, this is going to be one damn good bit of circuit, and I'm all for that. I mean, even these wires being, you know, having these loops in them, you know, some people might look at it and go, what, was the guy just, you know, did he do a messy job? No, that's because they're all the exact same length. It's all for electrical reasons. It's just like they're soldered exactly in the middle of each trace between the two resistors. I've done everything symmetrically. All right, well, I'm going to get these next 4 wires on the other heatsink, and then we'll start putting those sort of wiring looms, whatever you want to call it, together, wiring harness for the power, for the collectors, and then I'll solder a couple of bits of wire on the speaker outputs. I'm going to use some different wire for that. I've got some wire that's as thick as this at least, but oxygen-free copper. I know it doesn't need it. It doesn't make a difference. It's just I didn't want to use red or black again for the speaker output, you know. Anyway, I'll be back soon. I'm going to do that to this. Alright, that's the second one done. Whoops. So, came out a little bit different. Not as neat, I guess, because the way I put the resistors compared to the first heatsink just meant that the wires had to get routed slightly differently. See, I don't want the wires to be touching. I don't mind them like that, but I don't want them like that, because they'll capacitively couple and inductively couple. Alright, well, I'm going to make up these power distribution cables to get the power to the collectors, and we'll have a look at it. I'm just making up these wires, and I thought I'd just try and get this on video. So I'll get the helping hand out. I could go grab a different set of helping hands, but this looks like it reaches. So what I've done is I put heat shrink around the 2 small wires, so that then I can pick up the mating wire. Let me just crop a bit off because it's a bit too long. Alright. And I can basically force it in between the 2, and as you can see, that's already held in place quite securely. Now all I need to do is come in and solder it. Just make sure it's exactly how I want it. So now I'll solder it, and then I'll bring it up to the camera and I'll give you guys a look. Alright, I'll just have to wait a sec because there is actually quite a bit of thermal mass there. That's set. Alright, let me just, actually, you know what, I've got a little piece of wire sticking out. We don't want that because that can go through the heat shrink. That's the only bad thing about not twisting it together, I guess, is you can have that happen. But just take the focus lock off. And I know that looks a bit wiry there. I can put more solder on it. There is plenty there. It just looks like that because you can see the wires. My apologies for the crappy focusing. But as you can see, that is a very good joint. And now, what I'll do is I'll come in with this, cut a piece about that long. I'll put it over the joint. Like that. And then I'll cut a second piece. I'll come in, do the exact same thing. Now that is a very strong, well insulated joint. And now I've split one into two. And then what I'll do, I don't know if you can see those two holes, that hole and that hole, those are the collector traces. So this will just come up from the bottom, one wire in one hole, one wire in the other hole. It's a bit funny looking because the wire's not the right shape, but it's measured to the exact size. See? So there you go. I'll go make the rest of these up off camera now, but I just wanted to show that little technique for trying to join two smaller bits of wire to a bigger bit, where the bigger piece of wire is kind of too thick to twist it to the smaller bits, but you still want to solder it. So what do? Well, that's one way. I mean, yes, there are plenty different ways of doing it, but you know, I just figured since I've got the heat shrink out, because I'm already using heat shrink for this, I might as well just use a little bit to aid the process here. I'll just do this second black wire on camera. I think I got that one quite good first go. You get the hang of it quite quick. Yeah, that's come out perfect first go. So as you can see, it forms a very good joint. It's a perfect joint. There's nothing wrong with it at all. The wire is quite tightly touching, as you could see. I can literally hold one wire with the other piece, and then it's soldered on top of that. So, you know, it's quite a physically strong and electrically strong connection. And then there's obviously 2 layers of heat shrink going over it on top of that. So, you know. All right, well, I'll finish these up and then mount them to that, and then I'll give you guys a look. If anyone's wondering why I've done the wiring like this, again, this is all for perfect current sharing. Every single trace and wire is done to an exact length and symmetry for this exact reason, so that everything, you know, the transistors are all matched, even the components are matched. I mean, look, I didn't match resistors, but if I have offset issues, you know, something like that happens, I will be matching resistors as well. Capacitors, I mean, the ones in the compensation network have literally been matched. I mean, yeah, everything in this amp is high tolerance. So the way I see it, the more effort I put into it like this, the less room there is for anything to go wrong, and you know, the better the amp's going to perform. Anyway, I'll get the rest of this done off camera and I'll be back shortly. Alright, that's that done. So both the modules have a positive and negative. All those wires, I tell you, it makes it look a lot more powerful. So that's both of them wired up. I don't really need to put speaker output wire onto it yet, because when I hook this up for testing, I can just clip onto the output, you know, so I think I'll leave that for now. Same with the bias network and the base connections and all that. I'll wait until the other two boards that I'm going to start populating now are done, and I'm going to wire it all up, and then I'll lay everything in the case. That way I can see how long the wires are supposed to be, and I don't cut, you know, too long or too short of wire. And then I can take it all out and wire it up on the bench, make the final adjustments and whatnot, and then stick it back in the case. Alright, that is the drivers, the pre-drivers and the VAS transistors. Now I've got to put the driver transistors for the VAS, the beta enhancers. I've still got the current sources to put in too, which is this same model transistor. These are 2SA 1480 and 2SC 3790. You can have a look at the data sheet for those if you want. They're quite good transistors. That's why I've chosen them for the VAS and pre-driver stages. Alright, that's the VAS transistors and their drivers. So now I'm going to get the current sources on. Surprisingly, after they're on, I'm up to input pairs and current mirrors, which is quite a lot of transistors actually. I was going to say, anyone that looks at this and goes, oh, that VAS transistor is quite big. No, these are really small transistors. The die in there is smaller than probably a lot of TO126 parts, or at least the same size as some. Yeah, it would be smaller than a lot of them. You can have a look at the data sheet for these transistors if you want. There's a reason I chose them. The cob is like 1.9 picofarads or something. It's ridiculously small. The thing is, when you're building an amplifier that's, you know, 250 watts a channel or something like that, it can be quite challenging to find transistors with a high FT and low cob, low everything really, all the different capacitances that they have between their junctions, because, you know, as you go up in size, obviously the capacitance goes up. So basically what I've tried to do is select parts that have got high gain so that I can use smaller parts to drive them, if that makes sense. So, and let me tell you, that also can narrow your choice quite a bit too. But yeah, I've just spotted something I've got to go Dremel quickly. I'll go get that sorted out. Right, that's that fixed up. So now I'm going to mount some more transistors. I think what I'll do is I'll get, all of those mounted and then come back and we'll take a look. Well, I've just found the first mistake of the day. Having a look at my schematic to double check, sanity check that, you know, this is actually wrong. And yes, it's wrong. Even if I was still using this transistor, it would still be wrong. Oh, I hope I haven't done them all the same way. That's going to be annoying. I have. Ah, bugger. In my infinite wisdom, because usually I won't say usually, but I'm used to connecting the collector to the power rail, and because we're trying to use PNPs, when you're building an amplifier, you want your emitters to have some degeneration, so building the circuit like this works a lot better. I wasn't thinking about that when I laid the board out. So my pad that goes to a spot for a resistor to go to the rail is on the middle pin, and it's actually the emitter that goes to the rail on the current sources. And the problem with that is the emitter is the outside pin, this one. Same with these transistors. So I'm going to have to get creative, and I can already see this one's the same. Middle pin goes to the rail, middle pin. Yep, I've done it on all of them. Oh, I hate myself right now. Why the bloody hell did I do that? Oh well. I have to have a think about this. Do I want to bend the transistor legs around? I don't know. I could also... Yeah, I was going to say I could cut the traces and add some bodge wires or bits of metal, but actually I think it's going to be easier to bend the transistor legs. Ah, this sucks, because that's 8 transistors that will not just go on the board. That is annoying, and I really spent my time on this to make sure I got everything right. So yeah, I don't know how I did that. Originally I thought it was just because I've changed transistors, but when I got the data sheet for these, it turned out, I'm looking at it, well, no, it's not on the screen right now, I'm just getting it back up. Yeah, the emitter collector base, so that middle pin does not go there. Actually, all the pins are wrong. Wonderful. Alright, well, I'm going to work out what I can do in terms of bending these legs, and I'll show you my solution. So that's my solution. There's a good amount of gap between the legs the way I've done it. That's why I did it like that. Yeah, it looks a bit ugly, but like I said, there's a good amount of gap, and I didn't want to leave an inadequate amount of gap. Oh, this is going to be annoying. I still have to do this to another 7 transistors. As I was building this, I was saying to myself, because when I started this video, I picked the board up and I said, oh wow, this is going to be a monumental task doing all of this. And after I've just laid down 8, 9, 10, 16 transistors, I was like, oh, okay, this actually isn't so bad. I'm sort of breezing through this all right. And then I noticed this, and I was just like, hey, you got to be shitting me. Anyway, it is what it is. I'm going to take a break soon and get some vacuuming done, because I won't lie, this is stressing me out. The fact that I have to now do this. I don't know what it is about me. I mean, I do know what it is. I have a short attention span. I've been like that my entire life with absolutely everything. So I have to keep myself occupied by doing different tasks. I can't just do the one thing for a long period of time, if that makes sense. I have to break it up and do different things and then come back to the first thing a bit later. As long as I do that, I'm all right. All right, so that's the solution. It doesn't look too bad. There's a nice amount of gap around everything. I've seen other people cross transistors' legs on YouTube, and I can tell you now, I was horrified at the gap between them. So yeah, I'm impressed with that. All right, I shall continue. Alright, I am getting there. I just noticed that this transistor here was around the wrong way, so I've turned that around now. So if anyone noticed that, don't worry. I will keep checking as I go, so it's not really going to be a problem. Might as well have a quick look now. Yep. I'm going to do a good check at the end and double check pinouts and the right transistors and all that sort of stuff. This is worth too much to me to just, you know, risk blowing the whole thing up. 2 more to go of these annoying transistors. Well, I say that, but I don't know if I've done everything else right or wrong until I get to it. So hopefully these are the last 2 transistors I have to bend legs on, because that is already 1, 2, 3, 4. I mean, yeah, they're coming out all right. I'm not happy about the lead length. It means I've got to make the lead length a bit longer, but yeah, it's all right. Well, that's all of those transistors on the board now. So that's the current source transistors, the VAS section, pre-drivers. So now I've got to put the current mirrors and the input pairs on the board now. Once I've done that, I think what I'll go do, because I need to drill a couple of holes on this board. Obviously I need to drill, you know, a hole here and a hole here to mount the board, but this pad here needs to go to ground. It was originally going to a 100 ohm resistor and then to ground, but now it's just going to ground. So I need a little hole just next to that pad so a wire can come over and be soldered onto the pad. There are also a couple of other spots, not too many, but there are a couple of spots that are ground. For example, those 2 spots there, why did I do that like that? I meant to put a link between them. Oh, I know why. Because I was going to star ground it. Yeah, okay. So I've still got to drill holes and then I guess glob up a bit of wire underneath the center of the board and run it out to all those grounding locations. I'll have a think about how I'm going to do it. I want to make it the shortest path possible, so I might do 2 separate star grounds, 1 for each channel, and then run them back to the one main ground. You know, the amount of transistors that goes into this amp, it's insane. I thought I had matched all the pairs. I still need to do another 4 input pairs. So see that bag, how it has 2 transistors in it that are matched. I need to make up another 4 of these. It's insane. I've done all right with the current mirrors. I've still got, wait a minute, hold on, let me think about this for a sec. 1, 2, 3, 4 per channel. 1 channel, 2 channels. Yeah, I've got enough current mirrors. Input pairs, no, I need to make up another 4 sets. Oh goodness, this takes a lot of transistors, and I'm not even finished. I mean, after I get this running, get a quantisylum, do tests on it, I plan on adding regulation to the driver stage, speaker protection, all sorts of other things. The boards are going to get made up professionally. Oh my god, this is going to take a lot of transistors. I've got to admit, the final product will be very much worth all the research and building. Alright, that's the input pairs done on that board, and I've double checked to make sure that they're all correct. So now I have to, I think what I'll do now is I'll match up some more input pairs. So many parts, it's hard to get the right draw. So this is going to take some time. I'll do this off camera, but I basically need 4 more sets of input pairs. How fun. I tell you what, writing all these numbers down on the transistors packaging that it came in has saved me so much time. I've already got the rest of the transistors matched without even breaking out the DCA Pro and without breaking my what do you call it, patience. So I can continue building. The ratio of KSC 1845s to KSA 992s is quite interesting. I tried to see if I could just order 992s on their own, and I couldn't find any from the seller that I was getting them from, or from any other sellers that I know only sell legit parts. And so yes, that's how it is at the moment. Starting to look like something. When the current mirrors get on there, it's going to look crazy packed with transistors. And I don't even have passives on here yet. Alright. I shall continue. Alrighty, that's the input transistors. So all I've got left now is the current mirrors. We'll get these done. Probably in the video after I've got the rest of the transistors on the board, and then start the next video doing passives. I'm not too sure, I'll have to go and have a look, but I've just got a funny feeling that this video is already starting to get quite a bit long. Alright, so I've come across another little error. It's not a big one, but there's a pad there and there that doesn't go to anything. It's actually supposed to just connect to this pad here. This is just the current mirror. So that's where that base connects to the base collector, and that base should connect to this base and collector, but there's just no link there. Somehow I managed to forget to draw the trace in, and I actually etched it away, which is kind of sad. I think I'm just going to install the transistor first and then just drop a little bit of wire across to join the two pads together, if that makes sense. Let's see, emitter, collector, base. Yeah, everything else is correct. It's just that. So yeah, just a couple of links. Alright, I've got the current mirrors installed, and I've added the link that was missing to each side. So that's what it looks like so far. If I might say, that looks pretty cool already, and that's just the transistors. Well, I've still got this board to do, so I'll get to it. I might end the video after this because I've still got a lot more work to do, and because I did those power wiring harnesses for the collectors in this video as well, it's probably getting a little bit long. Oh goodness, I've found another error. So with the current mirror on the left, on the input side, you see the top transistor's base goes to the base collector joined transistor, and the second pair down is the base collector joined transistor. Well, on this side, it's correct, but on this side, I've got the joins on the wrong side. So top transistors should be joined on the right side, bottom transistors should be joined on the left. There's actually no join there at all. Don't know what I was thinking there. So yeah, I'm gonna have to pull these transistors off. 1 and 2, and do some dremeling, and then remount them, and then I'm going to have to join, probably just use a blob of solder or something because it's only like a millimeter gap, but yeah, I'm going to have to cut tracks and join anyway, it is what it is. So without further ado, I'm going to rectify the situation. Geez, that's going to be fun to get out. Alright, get a bit of solder wick on there. Spewing about this. I mean, it's not the end of the world. It could be worse. Alright, I'm going to go Dremel those two bits open. That is definitely what I did, isn't it? Oh, you know what? Wait, because this is mirrored. Hold on. So, oh man, I'm gonna have to stop and think about this. Maybe it's the other board that's wrong. I know one of them's wrong. Oh goodness. Well, it turns out they're all wrong. I'm just gonna have to do this in sections because otherwise I'll get all the transistors muddled up. So I need to cut this here too. Spewing. Not all I can do about it, just fix it. Right, well, that's that sorted. So what I'll do is I'll put these transistors back on. Actually, wait, what am I doing? No, that's the wrong board. Jeez, this is going to get confusing, I tell you. I need to finish this board, so I need to Dremel this and this. Oh, I'm just going to do one thing at a time. I'm just going to take it all back to the start because none of these are correct. So I'll get these all opened up and the transistors fitted in order so I don't get the transistors muddled up, and then we'll work out what goes where after they're on the board. Alright, so that's all the transistors fitted. I ended up just using solder to bridge those out because I couldn't get the link in there. It was a bit too fiddly. I mean, I could if I really tried, but this is fine. So, yeah. I want to do a little bit of work on camera because I always do all my soldering off camera. So I'm going to end this video here, and then I'm going to start another video where I'm just forming up component leads and making boards up whilst talking about stuff. So yeah, I'll leave this video here. If you like what you've been watching, and if you think this is a bloody brilliant amplifier, give me a like and a sub. Leave comments down below, and I'll see you all next time. Thanks for watching.